Welcome to day 57 of your 100 Days of Python Challenge. Today's project is an ASCII Art Generator. You'll create a tool that converts images into artistic representations using ASCII characters. Now, this project combines Python's image processing capabilities with creative output. Now, what will you learn today? First, understanding ASCII art basics. Next, we're going to look at loading and processing images. Next, mapping pixels to ASCII characters and generating ASCII art. That brings us combined together into day 57 project, the ASCII Art Generator project. So let's start with understanding the ASCII art basics. What is ASCII art? ASCII art represents images using characters from the ASCII table. Example can be at the rate, the pound sign, percentage, star, and dot. So you'll use all these. Darker areas of an image correspond to a denser characters, while lighter areas use less dense characters. Now, there is a character mapping for brightness. Now, characters mapped from darkest to lightest are in this particular format. There's first at the rate, then there is pound, then there's percentage, then there is star, then we have plus, then we have equal to, I think, and then minus and colon, and finally dot. Let me increase this in size so we can see. So these are different ones. If you have seen something where you have seen images created by doing all these using all these symbols, that's what ASCII art is. Now each character here corresponds to a range of pixel intensity values. So let's look at first loading and processing images. Now you need to install some libraries. In this particular case, I would need something called as pillow, pip install pillow. I'll make sure that I install it. I probably should already have it. That's why it says requirement already satisfied. But if you have not installed it, it will install it for you here. I'll clear it out. Next step is load and resize an image. Now, if you see, I have a bunch of images here. I have image of our president Donald Trump. We have my image, and then one more image of me. I have a bunch of them available here. So we're going to use those. And I have day57.py file here. So first, from pillow, we'll import the image. So from pil import image, that's what I'll do. So that's what I need. It's, I think, too big. Let's reduce the size. Next, to load the image, I'm going to say create a function called as load image, and the user will provide us the image path, and then I'll say new underscore width equal to, if the user has not provided with a width, I'll use 100 as default. First thing is to open the image. So let's see if the image exists. So I'm going to say img equal to, I'll use that image above, and I'll say open image path. So this will open the image. Now next, I'll go ahead and calculate the aspect ratio of the image. To calculate the aspect ratio is very simple math. What you do is you aspect ratio equal to image dot height divided by image dot width. So not familiar with this, this will give me the aspect ratio of the image. Next, I'm going to say new underscore height equal to int of, I'm going to say new underscore width, which is passed to us here, new width times aspect ratio times 0.55. Now this is the adjusting for character height. That's why this is added here. So next step is, let's go ahead and I'll say image equal to image dot resize. Now this needs one single tuple, and that is new underscore width comma new underscore height. That's what it needs. Now this is what I will return back based on what I've created. So this will load the image and resize it according to what we want. Next step is, I think we already covered the loading and processing images. Next, we're going to go into mapping pixels to ASCII characters. Now, how do we do that? So first, we need to convert the image to grayscale. For that, I'll create another function, convert underscore to underscore grayscale, and whenever the image is passed to me here, I will say, it's very simple. All I have to do is image dot convert, that's the function that we use, and to convert it into grayscale, you just give the attribute L here. That's it. Next we have to do is map the pixels to ASCII. So for that, I'm going to create map pixels to ASCII. So this will convert and create our ASCII, and it needs an image. Here I'm going to say ASCII underscore characters equal to the ones that I'm interested in is at the rate, percentage, then I'll use pound sign. Next I want multiplication. I'll use plus, we'll use equal to, we'll use minus, we'll colon, and then dot, and for nothing I'll use just empty space. And then I'll say pixels equal to image dot get data. This will get me the data for the image and pixels. And then I'll say ASCII underscore string. So this is the mapping here, where I can say empty dot join. Now based on the ASCII characters, so I'll say ASCII characters pixel divide by 25 for pixel in. So we have pixels available, so in pixels, so for each and every pixels that we get, I'm going to convert that into ASCII character and then join it to the pixel string, and that will give us the image. I'm going to say return ASCII characters, ASCII string, sorry, that's what I've created, so that's what I'll return back. So this will convert our pixels to ASCII. Now generating the final ASCII art. To do that, I'm going to go here and create a function called as generate underscore ASCII underscore art, and in here I'll take image path and I'll take new width, which will be by default I'll set it to 100. Let me move it down a little bit so we can see it completely. So first step is to load and resize the image. To do that, I'm going to call my function with I'll say image equal to, call the function of load image and pass it image path and new width that is passed to us here. Next I'm going to say convert to grayscale. Now this one I'll say gray underscore image equal to convert to grayscale and pass the image to it that we get from above. Next step is to map the pixels to ASCII. So I'm going to say map pixels to ASCII. To do that, I'll say ASCII string equal to map pixels to ASCII, and then I'll give the grayscale image to that. Next, I'm going to say I'll format the ASCII string into rows because we'll get a bunch of different string here. So let's kind of split that up. So for that, I'll say ASCII underscore art equal to, now how do you move the string to the next line based on the image size? I'm going to image, I'll say slash n, which is next line, join, and here I can say ASCII string inside this I is to I plus new width for I in range of, so now depending on how big the image is, I'm going to say 0 comma length of ASCII based on the string. I'm going to use that, and I'll look up the width, that new width that is passed. Based on that, it will create the ASCII art right over here, and that's what I'll return back. I'll say return ASCII art. This goes to the entire string that we get here, which is in a single line, and makes separate rows and puts them in a new line based on the character string. So that's what it does. So that's why we get the ASCII art at the end. Now I want to save this to a file. I can create a save ASCII underscore art, and I'll say ASCII art comma output path. I'll ask this from the user, and then I'll say with open, and I'll open a file based on the output path that is selected. I'll say in write mode, which means if it doesn't exist, it will create one as file, and I'll say file dot write the ASCII art at that particular location. Now if I just want to run it through one of my images, what I can do is I can just call this function, generate ASCII art, and this will give me what? An ASCII art. So I'm going to say ASCII art equal to generate, and then it needs the image path, and my image name is, let's say I'll take vivian.jpg, and then I'll say width equal to 100, new width is 100, which is default. So set that, and I'll say save underscore ASCII art. I'll call that function, and to that I'll give this ASCII art, and output path I'll say in the same folder, or I'll just give a file name. I'll say final.txt because it will be a text file. So go ahead here and run this python day57.py. So string has no object, so it looks like it's getting string back. So let's look at our load image path, new image, and this should, oh, instead of returning back image, I'm passing the image path. Maybe I auto completed it, that's why it didn't work. Let's go back here, clear this out, run it again, and there you go. My image is created. If you look here, this is what got created from this file. Not bad, right? So it looks almost same as the image. So that's what we are going to do in the next part. So our next part will be, we have already completed generated ASCII art, but our day 57 project, which is our ASCII art generator. Now we're going to take the same code path here. Just the thing is, instead of doing it automatically here, I am going to remove this here, and I create a main function, and inside this main function I'll ask the user print welcome to ASCII art generator. Next I'm going to say image path equal to input. I'll ask the user enter the path of your image, which I will be entering one of these, and then I'll ask output path enter the path of part to save the ASCII art, example output.text. So give me a text file path, and I'll say width equal to enter the described desired width of the ASCII art. Default is 100, so if you don't specify anything, I'll use 100. That's what I'm saying. Now I'm going to go ahead and try. I'll call this function generate ASCII, what we did earlier, generate ASCII art. Call that with the image path and new width, and then I'll save it to this ASCII art and output path. Finally, I'll say print ASCII art generated and saved to output path. If there's an exception, I'll print that exception error, and then I'll finally run the main application. That's pretty much it. That's the extra thing that I'll do here. Let's go ahead and run the program. I'm going to go back here and run it. Now it says, welcome to the ASCII generator. Enter the path of the image. I'll use this other one, image.webp. Now this image, if you look here, is this one. Let's look at it. What happens to that? Enter the path. I'll say vivian.txt, and it says desired. I'll leave it to 100 and go back here, and you see this gets generated from this image. Pretty cool, right? Next, let's try where Donald Trump. So I'm go here, clear this out, run it again, and then path is donald.png. Enter the path. I'll say donald.txt. Same 100 is fine. It says string index out of range. I think this PNG image has much more size to it. That's why it happened. If I go here, open this, and save this as, let's say, save as something more lighter. In this particular case, I will save it as a JPEG file, and I'll reduce the quality, and I'll say donald.jpg. There you go. Save, close this, and let's try it again. And I'll say donald.jpg, enter, and I'll say donald.txt, enter. Desired is 100, and it generated. Let's go ahead and check out the image it created right here. Looks pretty cool. Looks pretty close to what it is in the image, right? So play with it. Let me know how it goes. In this particular project, what we did was we took care of image processing. We loaded, resized, and converted images to grayscale. We did ASCII mapping, where we translated the pixel intensity values to ASCII characters, and finally we saved the ASCII art for future use. Bonus challenge for today is try to add support for colorized ASCII art using terminal libraries like Colorama. There's one that is available. Implement a live webcam ASCII converter. See if you can do that. Build a GUI with tkinter for user-friendly input and output. Try it out. Let me know how it goes. If you have any issues or problems implementing any of this, or if you have any questions based on what we covered today, let me know in the messages and I'll get back to you.